Hello class, and welcome to today's algebra lesson, which is about solving compound inequalities. By the end of today's lesson, you will be able to solve and graph inequalities with the word and or. So a little vocab to start today's lesson. A compound inequality is two inequalities connected by the word and or. If it is the first scenario, it's called an intersection. So these are the two inequalities that are connected by or. This only works so when you're solving the problem and you get your answers, the statement only is true if both of the inequalities are true statements. So it has to work, the answers have to work for both parts. The second option is the union, which is a compound inequality connected by or. This means that the answers on the number line only have to work for one or the other inequality. It does not have to work for both. It can work for both, but it only has to work for one or the other one. So we're going to start by just looking at some basic ones. We're going to start with the intersection. So we're going to graph this. The statement says x is greater than 3 and x is less than 7. So the first statement of x is greater than 3, I would start at 1, 2, 3 and put my open dot. And then if I test it, 0 is greater than 3 is a false statement. So I would be moving to the right. And all of these answers are true for this first statement. So 4 is greater than 3, 5 is greater than 3, 6, 7, 8, 9, 10, etc., etc., etc. All of those numbers are bigger than 3. Now, what changes with this compound inequality is it says it also must be less than or equal to 7. So I would come in and I would go 1, 2, 3, 4, 5, 6, 7, and I would put my closed dot. Then I've got 0 is less than or equal to 7, which is a true statement. So all of my answers for the second one should be going to the left. However, we have to stop at 3 because none of the ones below 3 work for the first inequality statement. So what actually ends up happening here is these values above 7 are no longer part of our answer. So the only answers that work are between 3 and 7 because this is an and statement. So 4 is bigger than 3 and it's less than 7. 5 is bigger than 3 and it's less than 7. 6 is bigger than 3 and it's less than 7. So all of these values on the inside of those two dots make up the answer for this intersection. You can also see intersections written as this one big inequality statement. So this is read as 6 is less than r plus 7, which is less than or equal to 10. When you solve this version, if you take away 7 from the middle, so between the two inequality signs, you have to take away 7 from both of the outside values. So our final statement then becomes -1 is less than r, which is less than or equal to 3. The nice thing about writing it this way is it tells you exactly what you are in between. So I would go to -1 and I would put my open dot at -1 because there is no equal to part there. So I've got my open dot, oopsies, at -1, not -2. And then I go to the right, 1, 2, 3, and put my filled in dot. And then my answers for this compound inequality are between those two dots. So all the values between -1 and 3 work for this answer. You can also see inequalities with the intersection written separately, where you would have to solve them both like normal cases. So I want you to go ahead and solve this one on your own, telling me the two answers for the inequalities, the two dots that you would get, and then where you would draw in that answer portion of the graph. So your first answer is y is greater than or equal to -8, and your second answer is y is less than or equal to -5. So it should have been both closed dots, and the answers are between those two dots. Moving on to the union now. This is the part where it has to satisfy one or the other. So starting with the basic one, I've got x is greater than 2. So I'm going to go to my graph and I'm going to put my open dot at 2. 0 is greater than 2 is a false statement, so we are looking for the values going to the right, all of those that are bigger than 2. For the second one, I've got that x is less than or equal to -1. So I come over to -1 and I put a filled in dot. Now I've got that 0 is less than or equal to -1, which is once again a false statement. So in this case, we are moving to the left. So what this means is that the green answers work for the first part, but not the second one. And that's okay, because it only has to work for one. The blue answers work for the second part, but not the first part. Again, that's okay, because it only has to work for one or the other. So this part, we don't have to erase anything as we are on the graph, because it can work for one or the other. So now when we get to solving these, this first one, I've got b plus 6 is less than 15. So I'm going to subtract 6 from both sides of my equation, and I end up with b is less than or equal to 9. So I'm going to start at 9 with a filled in dot, and I'm going to test my point of 0 is less than or equal to 9, which is a true statement. So I want all of those values going to the left, which are smaller than 9. With my next statement then, I am going to subtract 2 from both sides of my statement. So I have 4b is less than 8. And then I'm going to divide by 4 on both sides, and I end up with b is less than 2. So I'm going to come over to 2. I'm going to put an open circle there. And then I'm going to test a point. So 0 is less than 2 is also a true statement. So once again, I am moving to the left. So what this graph shows is that where the red and the blue overlap, that works for both, which is great because it means it works for one of them. Where the blue is by itself, that only works for the first one and not the second one. Again, that's fine because it only has to work for one of them. And then this area up top where neither the blue or the red is, those are the numbers that don't work for either statement. So go ahead and try this one on your own, saying the inequality, the dot, and the direction for both statements. So when I solve the first one, I end up with a is less than 3. That's going to be the open dot going to the left. And when I solve the second one, I have a is greater than or equal to 7, which is a closed dot going to the right. When we have word problems, there's a couple different scenarios here. We have to decide if there are intersections, the and statements, or unions, the or statements. So I read the sentence, a company makes action figures that must be at least 11.2 centimeters and at most 11.6 centimeters tall. So the first thing we need to do is decide, are we trying to be between, with the and statement, between those two numbers, or outside of, going either direction. So in this case, it says the first part is I want x is at least, so greater than or equal to 11.2, and we have x is at most, so less than or equal to 11.6. This is going to be an and statement, so you can write it as two separate pieces, or if you prefer, you can write it in that compound form for an and statement, which is 11.2 is less than or equal to x, which is less than or equal to 11.6. Now I'm going to come down to my graph, and I'm going to put a closed dot at 11.2, a closed dot at 11.6, and then connect them because we are looking for those values in between those 2 points. Go ahead and try this one on your own. First, I want you to just write the inequality. So when I write the inequality, I have x is less than 20 on the low end because that's outside of what we can hear on the low end, or x is greater than 20,000. That's going to be the upper end of the problem. Now explain to me how you would graph this inequality. So on the left side, we have an open dot at 20 and the values are moving to the left, smaller than 20. On the right side, we have an open dot once again, and it is moving to the right. Final piece here, if they give you the inequality and you need to, if they give you the graph and you need to write the inequality. When we do this, we want to treat each side of the graph as its own separate piece. So when I look at this first part, I am 1, 2, 3, 4 below 0. So I'm at -4. And my values here from this line are getting bigger than -4. So my first one, I've got x is greater than -4. Because it's between, this is going to be an and statement. And then on the second one, I'm at 1, 2, 3, 4, 5, and those values are going to the left. So smaller than 5. So I've got x is less than 5. So that's how we can write it with the actual word and. If you want to write it in compound format for the and statement, it would be -4 is less than x, which is less than or equal to, almost forgot the equal to part there, than 5. So either of those answers would be acceptable for this graph. Go ahead and try this one on your own. This one is an or statement, so I've got x is less than or equal to -6, or x is greater than 1. You also could flip if the numbers are on the left or the right side of that inequality sign. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.